Good to be back in Linköping. I'm going to speak in English. I hope that's okay. I used to work for Ericsson for many years, so Ericsson is very active in Linköping, so I was here quite some time. And even before that, I was doing military service, conscription service, and then I was at Malmslätt a couple of times, but I cannot tell you anything more about that because that was the Swedish signals intelligence. And then I have to kill you, and I don't want to do that. So, concurrency-oriented programming. So, concurrency, that's beautiful, right? And a lot of people talk about object-oriented programming. I think that's interesting, so I will give you another perspective, because the world is not static, it's dynamic, and then you need concurrency. And why do we talk about this? Well, you heard about the X factors. Jan Bosch talked about 20X, and I will give you 2 times 10 times 10 times 10 times. That's a lot of X. It's more than 20X, and you can pick the one you need. You know, faster, better, safer, more for less. And I have data to back this up. You have the references, you will get the presentation. But you know, small companies like Motorola, Ericsson, WhatsApp, and BBC use concurrency-oriented programming and get these figures. So it's facts, it's science. And then common vulnerabilities and exposures database that we all love and trust, right? So that's the topic for today, why we talk about concurrency-oriented programming. Little commercial break, or as they say in the US, technical timeout. As I said, I was at Ericsson for more than 20 years. I'm a hacker at heart and for real. I did some software research at the Swedish Institute of Computer Science. And I'm an Erlang fanboy, and for some of you, you may realize that there's a connection between concurrency and Erlang, and that's what we'll talk about. Repeat again, the X factors, 2x, 10x, 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 a lot of X's, and I will tell you more about the secret sauce. Starting yesterday, what was the job to be done back in the day? Quick recap, telecoms world, global voice calls, 60s, 70s, 80s, 70s, 80s, 90s, mobile voice calls. Some of you may have been involved in this. I see people in the room who I know were involved. Then smartphones, mobile apps, 2010, 2020. This was the telecom world, and this still is. How do you handle this? There were a number of people working on this. There were needs. Mike Williams, Bjarne Decker, Joe Armstrong, Robert Verding. They were working on this from the mid-80s onwards. Mike said that, well, prototyping is important. It's not enough to have ideas. We need to try them out for real to be sure that they work. And you shouldn't do that in projects. You should do that in separate activities. But trying things out, experimenting, iterating incrementally, super important. Bjarne, he talked about real time. Well, it's telecom, right? It's not hard real time. People don't die if you miss out, but indirectly, because it might be an ambulance or a firefighter that needs to get there on time. Secure, very important in telecom. Scalable, you know, millions of people. It's pretty important. Finally, Joe, he talked about reliable distributed system in the presence of software errors. And the key thing here is software errors. And if you read his thesis, this is the title of his thesis, it's not only about software errors, because in the telecom world, you have hardware as well, and hardware breaks. So this is fundamental. This is the real world. This is not theory. This is not computer science. This is real engineering where you need to make things work. So these gentlemen and Robert, they started to think from first principles. They had time. They were not software engineers. I mean, Joe was a rocket scientist working for Rymdbolaget. Mike was a telecom engineer with an engineering degree in electronics engineering. Robert was a physicist, and Bjarne, their manager, I mean, I don't think they had engineering degrees in software at that time, but they were solving real problems. So they were problem solvers in the sense of engineers doing that. And the first principles that they started from were the following. The world is concurrent. Things happen simultaneously. And the world and things in the world do not change data. Things communicate with messages, and things fail. So this is like first principles for telecom, but not only for telecom, but for the world. Because a lot of the things that are applicable in telecom are applicable in all infrastructure, digital infrastructure critical for society, where telecom is one example. You can think of fintech these days, you can think of defense, you can think of digital health, you can think of media. All of these are digital infrastructure critical for society. And these are the first principles where they started from. And this was from Joe. He sort of summarized this after a few years, so it's a bit of hindsight bias. So let's talk about these principles. So concurrency, you may think it's simple, it's just, many things going on at the same time. But if we distinguish between concurrency, parallelism, and distribution, concurrency, run many tasks on one unit. You slice and dice, you have a scheduler, one processor. Parallelism, you run many tasks over several units. Think of a multi-core architecture these days. But when they started, back in the 80s, there were hardly any multi-core architectures. These came later on. So this was state-of-the-art in research in the 90s. Moving on then, distribution. You run many tasks on several units, sort of wherever. Doesn't have to be on the same machine. It can be machines wherever in the world, and then of course you have latency and whatnot to handle. But the cool thing is, based on this first principle, the key insight was you want to automatically handle concurrency, parallelism, and distribution in your programming language or in your virtual machine. So you don't need to think about it. You have another abstraction layer in your programming language. So the virtual machine and the underlying environment will handle this for you. Then you can focus on the business side of things and the business problem and the domain-specific problems, and let the machine do what the machine does best. So that was principle 1.1. The world is concurrent. 2 and 3, don't share data. Communicate with messages instead. Don't use a shared memory. Send messages. Because if you treat your processes as immutable data structures, you will have much easier way to handle distribution and failures. And remember, we're going to talk about principle 4, handle failures in a smart way. So shared memory, of course, you can do that, but it requires much more work if you're going to do distribution and if you're going to handle things that fail, because it's connected and you want to disconnect. That's the key thing here. So principle 4, things fail. Anything that can go wrong will go wrong. Edward A. Murphy Jr., aerospace engineer in the late 40s, also known as Murphy's Law. What if you start with this as your fundamental principle for designing a programming language? Well, then you can come up with things like supervision trees, which will isolate failures and handle automatic recovery of the system. So let the small isolated parts crash responsibly to safeguard the overall system. Think of a telecom switch. You don't want the switch to crash, but it's okay if a single call goes down because you can set it up again. So sometimes people misunderstand this, let things crash. It's, let things crash responsibly by having the system handle it for you through the supervision trees. So it's about automatically embracing failure rather than preventing failure. So again, a first principle that sort of sets the scene for the whole programming language and the whole environment. So these were the 4 simple first principles, and that takes us to today. So what is the right tool for the job? We talked about digital infrastructure critical for society. You want to have high security, you want to have, no crashes, no bugs, or as few as possible. And we heard about Jan Bosch challenge, the 20x. How can we do that as software engineers? So why Erlang and Elixir? Don't take it from me, take it from Robert, one of the inventors. He invented, or he came up with the first rule of programming, and you can read it here, I will read it for you. Any sufficiently complicated concurrent program in another language contains an ad hoc, informally specified, bug-ridden, slow implementation of half of Erlang. So Robert stole this, he changed it slightly, but his point is that you get a lot of things out of the box. You get a lot of things for free because you have a virtual machine that has been developed since the mid-80s. You don't need to think about a lot of things. If you do things in Rust or Golang or your favorite language, of course you can do this. They're a Turing equivalent, right? But what you get from Erlang and Elixir is a battle-tested virtual machine that covers all these concurrent things that we talked about in principles 1, 2, 3, and 4. It's out of the box. You don't need to do it yourself. And you don't need to think about the concurrency, the parallelism, and the distribution, because it's sort of built in. I'm going to pause here for this wisdom. Take it in. And if you have questions, by the way, shout it out. So Erlang, the programming language, functional declarative, and I think we had that on one of the charts in one of the sessions earlier, one of the ThoughtWorks charts. They were talking both about functional languages and concurrent languages. So meaning that you have another abstraction layer, and means you need to write fewer lines of code, and we all know that the number of bugs is linearly dependent on the number of lines of code. So if you have a factor 10 fewer lines of code, that's a good thing. We talked about immutable data and message passing. It's all in there. Concurrency and error handling primitives are sort of built in from the beginning into the virtual machine, into the language, into the syntax. It's open source since 1998, where hardly anyone knew what open source was, at least not outside of the software community. And some people say it's the best European open source since Linux. And then I haven't even talked about the OTP, the Open Telecom Platform, which is sort of a set of tools, libraries, frameworks for building these kind of mission-critical systems. So that's Erlang. Now we have the little sister, Elixir. So this started out as Ruby people having problems with quality and scalability. So they went out looking for a good virtual machine, and guess what? They found the Erlang virtual machine. So they took all the good stuff from the Ruby community, the syntax, the developer experience that has always been fantastic. So a lot of people from the front-end world using Ruby, they went to the Elixir language because they got the virtual machine from Erlang. They got the nice environment for building these scalable and high-quality systems, and a little bit of Ruby syntax, and a little bit of Ruby community magic, and closure. So again, functional inspiration. So the add-on is the front-end focus, which was never a good thing with the Erlang community because people came from a telecom background and they weren't really interested in front-end stuff, frankly speaking. But the developer experience is truly amazing here. Look at the Stack Overflow developer surveys from 2022 until this year. You have Elixir being top 2 or top 3 of the most admired languages, Rust being number 1, because when you start to use it, you want to continue using it. It's not the most used, but the definition of admired is you have tried it and you want to continue using it. And Phoenix Live View Native has been the top 1 web development framework for the past 22, 23, 24, 4 years. So it's pretty cool. Sure.
Is it the same syntax done in the back end and the front end when you're using this Elixir?
Yes, it is. Yeah. Thank you for asking that question. You're jumping ahead into the presentation. But I can take that right away because that's really a cool thing, because you can, if you're a startup, you can be a startup of 1 or 2 if you want to have redundancy because people might get sick or want to take vacation. then you can build your whole thing, your backend, your front end, and even your apps, be it an iOS app or an Android app, because it's this Phoenix Live View native thing, where the native is for app development. And we've seen a couple of startups doing exactly that. Rather than having a front-end team and a back-end team and an app team and a lot of ping-pong back and forth and quality problems and APIs and yada yada, you can do it full stack. So thank you for asking that. It wasn't planted, by the way. Okay, so just a few logos. You see the telcos at the top. Some cool companies like Apple and Tesla, Toyota, Volvo, TV4, Klarna, MasterCard, BBC, Financial Times, and RabbitMQ. Who uses RabbitMQ? Everyone else uses Kafka. No, but RabbitMQ is written in Erlang. You know, write once, run forever. It's a really cool thing. Just works. What about tomorrow? What's the future? Of course, it's bright. Very bright. So bright, you got to wear shades. So what's going on in the community is typing. Some people like typing, some people don't. I'm kind of in between. I'm a consultant, so you know, pros and cons, either. It depends. But gradual typing is entering the Elixir space. So you don't need to think about it until you want to think about it and be explicit about it. And it's totally backwards compatible. But again, tabs or spaces, typing, not typing, Emacs, Vim, well, you see where I'm getting at. And to your point, to your question, even faster with the full stack development using Elixir for the backend, for the front end, and for your app development with this fantastic developer experience. When it comes to AI, since it's done for parallelizing things automatically, when you have a lot of data and you have a lot of LLMs that you want to ingest data and control the stuff, so then you can complement whatever your Python stuff is with it's like an Elixir orchestrator, if you will. And there's a cool Finnish startup that is using Elixir for this specific purpose. So that's another cool thing going on. And then it's backed by WhatsApp or Meta because they use it for WhatsApp. You know, the backend is written in Erlang by a team of, I don't think it was 15, 16, 17 people, big two pizza team that did this over a period of 6 months. And if you use Facebook Messenger, Facebook had to replace their Messenger and they took in the WhatsApp Messenger because it didn't scale with quality. So they are a big stakeholder in the community, so they contribute a lot to each new release of Erlang and OTP. Of course, Ericsson is using it. I don't know how much I can say because this is being recorded. But there are base stations out there. There are control systems in those base stations, and there are new generations coming for 4G, 5G, 6G. So strong backing from big players in the industry, WhatsApp and Ericsson. So it's a very bright future. And then there's something called Erlang Ecosystem Foundation. It's like 1,000+ organizations, large and small, that are working pro bono to make the ecosystem, thriving and growing. And with that, I'm going to summarize. Repeat again, 2x faster, 10x better, 10x safer, 10x more for 10x less. And as we heard before, if it's less than 10x, don't even bother. So I want to try it out. It's perfect for digital infrastructure critical for society, be it fintech, digital health, media, telecom, defense. And don't take my word for it. Stack Overflow, if you try it, you want to continue using it. And then it's a matter, do you prefer more Prolog syntax, then you go for Erlang. If you prefer more Ruby-like syntax, then you go for Elixir. Try it, you will like it. And I will now leave the floor open for questions. Thank you.